Just the grade, and then they're worth their percentage. So here's something like 3b. Everybody had a problem that looks something like this here. What you got, Jeff? Sure, man. Why everybody's 3b looked like this somehow? You guys had 3 and 15, some of you guys had whatever. I can't remember. So the idea was, what can I do with these two numbers? Since they're both in square roots, what can I do? What's the square root of 3 times the square root of 21? It's the square root of 63. That's awesome. So it's the same thing we've always done. What's 3 times 20? What's 3 times 21? 63. So what's the square root of 3 times the square root of 21? It's the square root of 63. As long as they have the same root, I can combine them. I can put them together. All right? Now what can I do with this, though? A lot of you guys got to the second step, but you didn't get to the third step, right? Bam. What can you do with 63? 9. 7. What's the square root of 9? 3. What's the square root of 7? I don't know. So everybody's 3b works like that. It's not the same numbers, but it's the exact same problem. Don't you love that? Do you understand? If you understand what I just said, you understand math. Everybody had exactly that problem. You just didn't have the same numbers. I love that. You guys are looking at me like, I knew you were insane. All right. There was something interesting that happened. Not everybody did this, but enough did this that got me worried. Like if I had, what do you have, Jeff? I don't know, man. Yeah, sure. This. And people would do this. They would break this up. This is beautiful. This is looking great so far. I love the idea. I love what you're doing. Everything's awesome. And then this is the answer. You saw numbers and you put them in. But that doesn't make any sense. What's the square root need to have something come out in front? And what does it need to see inside of it? What's the square root need inside of it for it to be done? What's the square root need versus a cube root? What's a cube root need? What's a fourth root need? What do they need inside to be able to be done? Why can I do the square root of 9, but I can't do the square root of 3? Because 9 has 3 only has 1 3. 9 has 2. There it is. Look at that word. Square root looks for 2, right? Because what's the root understood to be? 2. What's a cube root look for? Groups of 3. Oh, it's silly. So that's why we put the little number out there. So I know how many groups I'm looking for. So what are their groups? So this is wrong. What is there 2 of? Because this is square root. What is there 2 of? 2. So there's a 2 that comes out. And what is there only 1 of? Oh, poor little 5 dude. Right? So there's a lot of different ways I've heard this explained. It's like this is the power of the prison. You need 2 people to be able to break out, and one of you die on the way out. There's only 1 5, whatever. I don't like that personally, but right, you can't put the number out because that's why I prefer this. I prefer this way because you can see exactly why the numbers are where they are. Break 20 up into a square rootable number times something else. What is the square root of 4? 2. What is the square root of 5? I don't freaking know. I mean, that's why I like that way better, because you can see exactly where everything's coming from. This way, a lot of you guys do this kind of mistake, because you just see numbers and you put some numbers down. You don't really follow where things are coming from. Okay, so I was in a mistake that just came to my mind.
40.
When you have rational expressions, what cannot happen in a rational expression? What can't happen in a fraction? Yeah, you can't have 0 on the bottom. So if you have variables on the bottom, well, let's call this g of x. This is related to number, what was it again? 4e. Domain of g. So what did we just say cannot happen? All right, so that's can equal 0. So the bottom. So in English, the bottom can't equal 0. There it is in English, right? Believe it or not. You're like, some of those letters look Greek. It's English. Now, how do you write that same sentence in Mathish?
X cannot equal 8.
The bottom. What's the bottom? What's the bottom? What's on the bottom? Just say it. What's on the bottom? X minus 8. There you go. So the bottom, x minus 8, the bottom cannot be 0. Now solve that. And that's your domain. Your domain is everything except that. That's the number that would make the bottom 0, and you can't let that happen. So if you solve this,
All real numbers except 8.
all real numbers except 8, or I would take that too. That's basically what that says. X can't be 8, so that means x can be everything else. Now some of you guys are like, why'd you do all that shit? Because you could just see it, and I love that. It's awesome for you guys. For everybody else, I want you to realize, anytime I ask you the domain of any function, say in English what can't happen, and then write the same thing you just said in math, and then solve it. It's crazy. It will always work. Remember that. If any of you gets a pre-calculus, just go, oh yeah, Jeff said that way earlier. I know all these freaking functions, but the domain is always, I just say in English what can't happen. So everybody had a problem. Everybody had this problem, but nobody had these numbers. I like it. Yes, ma'am.
Can you do your 1C? 2x squared plus 3x squared minus 2x.
Yeah, so everybody had a problem on 1C. Everybody's problem was related to it wasn't equal to, what's it got to be equal to on 1C to be able to do that problem? 0, because there's the x squared stuff in there, right? So everybody had a problem like that. Some of you guys had different stuff on the different sides, right? So let me see. Somebody make a problem like what was there. You could do it, Jeff. Can you do it, Jeff? See what happens. See if that works.
Does not look like the one on my paper.
It does. It's exactly the same as yours. It's exactly the same. Believe it or not. You said yours was 2x squared plus 3
Yeah.
equals x squared minus 3x plus 7, right? That was yours? All right. That's
Okay. No, I just got the other.
no. Is it all right?
No, it's like 2x squared plus 3 equals x squared minus 2x plus 6.
Oh, all right. But I want you to understand, it's the same thing. Because what's important in math is the idea. The individual numbers you have to worry about because you have to know what 3 minus 2 is, but the process you follow doesn't care what numbers are in there, what coefficients are in there. Who cares? Math doesn't care about that. We do. But what tells me what to do here? What's not right? What's supposed to happen? What's supposed to be true in order for me to try to solve this? What's wrong here? Why was 1b easy? Because it was already what? It was already equal to 0. Do you see what I'm saying? So it doesn't matter that's a 2 and that's a 1. Who cares? The idea is make it equal to 0. So how do I make this equal to 0? Keep going. Yeah, so subtract 2x squared, subtract x, subtract 4. So on this side I get 0. On this side I get x squared minus 5x minus 4, right? And really, see, this is what I was trying to do. So give me a break here. I was trying to make one up in my head. It should really be like that to make it work. All right. And then what do I do with this? Factor, yeah.
-4 and 1.
Yeah. So x equals 1. Some of you guys, a few of you guys get to that step and then just stop. If the problem says solve, you stop when you know what x is. Or you stop when you know that nothing works for x. You don't stop until you get there. Right? So always pay attention to the instructions. If it says solve, if you don't figure out what x is, you're not done. You're not quite done with it. Yes.
3C.
Oh, so this was kind of the reverse of 3B. Or sort of the same thing on the second step. So everybody's 3C. I think everybody had a cube root there. So everybody's looked something like this. Sure, that one. Nobody had that number, but everybody had that problem. Just don't get used to that. Jeff just says weird shit. That's whatever he wants to say. What would be smart to break this up as?
You divide it by 2. You divide it by 2.
Right.
Oh, okay. All right. So you could just take 80 and break it all the way down. So well, if I did that, so that'd be 2 times 40, 2 times 20, 2 times 10, 2 times 5. And now what am I looking for? If I do it this way, what am I looking for?
3 of 2.
Yeah, I got 1, 2, 3, 2. So what happens to these guys?
They stay in the right.
They stay inside. There's not enough of them to make it out. So what do I put out front for these?
3. Or 2. 2.
I put 1, 2 out front because I saw one group of 3 2s. So I put a 2 out front. And what's still inside?
2. 10.
Yeah. Because a cube root cuts things in thirds. So it can only do that nicely if there are already 3 of something in there. Anything that's there's only 1 of or only 2 of, just stay inside. I can't do it.
Yeah, when I was factoring down the 10, like I put 5 times 2, and I guess I got the 5 wrong for some reason.
No, you just your answer didn't have the 5 in it, right?
No, I just put 2 for my answer because I had 3 2s. Like,
So what happened to the 5 is my question. It doesn't just kind of like dissipate, right? It's got to still be there somewhere. So that yours, it would have been left inside.
yeah.
You see what I'm saying?
So it would be like 2 to the square root of 5.
Cube root, I think it was.
Okay, yeah.
And be careful with, don't forget this poor little dude. A lot of you guys had put the 3 in for you. I didn't take any points off. But you can't have the cube root magically become a square root, right? It's got to go through a whole procedure for that. What else was I going to say? Oh, the other way to do this, this is one way to do this. This is beautiful. If you do it this way, kick ass, right? The other way to do it is a little more direct. What number goes into 80 that actually the cube root can do? 8. So this would be the cube root of, become a 3, Jeff. Good job. Cube root of 8 times the cube root of 10. Cube root of 8 is 2. Cube root of 10 is, I don't know. Do you see why I prefer that method? I prefer that method for a couple of reasons. 1, it was quick. 2, I can see where things are coming from. I can see it happening. Right? This is a little bit more, you got to understand the idea of it to do it this way. And depending on the number, this could take a long time to break it down into its DNA. A little math biology. Yeah, Asia. Oh, okay. Okay, so everybody had a problem that looks something like this. Did I put a minus in there? Yes, I could. What kind of problem did I make it? Okay, good. We like it. So this is like 2B. So everybody, yeah, same thing I was saying. So what do you do first on this? What do you need before you can do anything here? There are actually, I'm glad you're asking this question. There are way too many mistakes. If you cross through something, you must be able to identify why it canceled. Why did it go away? So I had way too many people do the first step correctly, but then start killing things. What could kill division? What's the only thing that can kill division? Multiplication. Is there any multiplication happening? No. So nothing can die. Oh, which is kind of nice. Huh?
Open.
Yeah, so first thing you got to do is what? Factor it. Right. So thankfully, there's only one person I think that's evil for me to say that, but it's too late, I already did. That gave this guy all of this and this guy all of this. Right? You don't need to do that. They're not missing each other entirely. They got bits of each other in them, don't they? That just sounded weird, but oh well. What's x squared minus 16?
X plus 4 is
And how do you factor this guy? Oh, but anything is a 4 there, right?
6 and 4.
Yeah, 6 and 4 is 24. Which one's got to be positive?
6.
Careful, the bigger one. So I'm busting in all my freaking colors on this problem. What's this guy missing? So a lot of people got here and they killed the x minus 4s. They just disappeared. And even if you could do that, which you so desperately can't, do these have the same denominator? So you couldn't put them together anyway, right? So these cannot cancel because they're not doing opposite operations. They're both on the bottom, and it's subtraction. There's no way they could kill each other, even if it was multiplication. Do you guys see that? So what is it you do? How do you make them have the same denominator?
You gotta multiply x plus 4.
Yeah, what's he need?
X plus 6.
Yeah. He's a little kid saying, you got an x plus 6, and I didn't get an x plus 6. I'm like, all right, jeez. What's this guy need?
Nothing.
He needs something.
Oh, x plus 4.
He needs an x plus 4. And now they both have, bam, 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 they both have the same bottom. And we know to do fractions, I can only add and subtract if they are like terms, if they have the same denominator. So now I can do what? What do I get up top here?
5x plus 30.
5x plus 30, good. A lot of people just forgot to bring, and of course what happens here?
Negative 2x minus 8.
Good, so a few people forgot to bring that negative through, which is an easy mistake. It's evil. Negatives are kind of evil. All over, bam, 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 right? This stuff. And then you just do what to the top? Now it's cleanup time, right? Now you just put your like terms together. Right?
How about 2C?
Blah, 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 blah. So a few people, real quick, sorry, a few people had this kind of go away. It can't just go away, right? If I have 2 7s minus 1 7, that can't become 1. 2 minus 1 is 1, the 7s go away. What? I didn't have a full thing and I took something away and now I got a full thing. I wish, that'd be awesome for gas. I'd save a lot of money. 2 7 of a gallon and now I got a full gallon, a full tank. It's awesome.
So this is the last step.
Yeah, sorry. Of course, you write those in.
Yeah. I mean, that's it.
Yeah, because I can't reduce the top.
C, 2C.
Oh, okay. So 2C. Make one up. Did you have a specific? Everybody's 2C, there was a cubes in it. So everybody's 2C, there was a 3-term dealio that was related to the big dude. So if you guys just gave up when you couldn't factor that 3-term dude, don't give up, shit. It could be part of something else. So you do everything you can do. Don't give up when you hit the first one that you can't do. Maybe it's not factorable. This time it was GCF, that's all you could do. But then it was the big dude. So they would the big dudes would just cancel each other. So I think if I remember correctly, everybody had a cubes on the bottom of the first fraction in 2C. So you just have to factor that correctly. GCF, the 3-term dude, and then factor the other guy. If you factor everything, you see a lot of stuff cancel. Should have quite a bit of stuff cancel. Was there a piece of it that... Oh, this guy's got to be the little dude, big dude.
Oh.
Right? Yeah. Cool. And then this guy won't factor at all. This won't work. This top guy's only GCF. Yeah. Cool. And don't forget, today is also, it's not just correct test for day. It's also, prepare for the final exam that's coming on Tuesday. So let me go ahead and give you guys the answer key because it's going to take me a little while. I'm going to have time to staple them. Oh, scheisse. Oh, good. Yay. All right. So this first one, make sure it's got a front and back to it. The second sheet's only one-sided, so that's pretty good. So, there will be some word problems, there will be graphing problems, there will be systems of equations, substitution, elimination, that kind of stuff. Remember that stuff? There will be order operations problems, a little bit everything. We'll have a little bit longer than normal for the final, but I'm not going to make the test like a lot longer or something. The test won't be able to, the final won't be able to be much longer than a normal test, right? Because we don't have that much more time for the final.
Can you do number 4 in the test A, please?
4A. Was there something freaky about that one? Oh yeah, there is something freaky about it. So what happens when you solve an equation and all the x's cancel? What could be true? So if I have this equation and I get there, what does that mean? No solution. There's no way to make that true. There's no way to make that true, so there's no answer. No x saves this. What do you add 1 to? And it's the same as adding 2. What the hell? There's no number that does that. There's no solution. But how do you get infinite number solutions? How do you get all real number solutions? What do you have to end up with to get all real numbers as an answer? Yeah, it's got to be a true statement, right? So if I had this here, 2x plus 2 equals 2x plus 2, subtract 2x, 2 equals 2, that means all real numbers work. This is a definition. That's really what it tells you, is this is always true. No matter what x you put in there, distributive property works, period. So that's why I expect to be get out of their end. All real numbers. So remember those special cases. So 4A is one of those special situations. I love it how you guys are like rescue personnel for X's. It's about to die and you save it somehow. So here you're like, no, the X is still alive. It's dead. It's gone. Let it go. Don't die on the X. Yeah. Oh yeah. The dreaded 1A. And this is not to make you feel better about not being able to deal with fractions, but I have calculus students that have trouble with fractions, which just makes me cry late at night. I just sit up in my bed, just tears. So this is a combination of things. When is order operations true? When do you have to worry about order operations?
All the time.
I love it. Danny's like, I got your tricky question, Jeff. Stop with that shit. All the time. All the freaking time. Doesn't matter what chapter you're in. I'm not in a chapter of order operations. Who cares? It's the underlying grammar of math. It's always true. So what is it I do first, of course, up here?
Solve the number.
Well,
Parentheses.
parentheses. I love it. All right, please. So I have to do inside here. And before I can subtract these two, there's two things. That's only one thing I really have to do, but there's two things I could do to make it easier. One obvious problem is what?
Solve the
Turn make like denominator.
Yeah, they don't have the same denominator. But something else you could do to make things easier is to turn.
Proper fraction?
Huh?
Is it proper fraction?
Yeah, make it into an improper fraction, right? You guys kind of with me? So you could just not do that, but it's going to help you later with this. So we might as well go ahead and do this. How to make this into an improper fraction?
16 over.
Yeah, 5 times 3 is 15 plus 1 is 16. Hey, you're better. Get out of here. And then, of course, now I need to do the other thing we said, like denominators. So I multiply by 32 tenths minus 1 tenth. So inside now I get, careful, what?
31.
And I can, division is multiplication by
Reciprocal.
the reciprocal. And then what beautiful thing happens here? Yeah, don't multiply first. That sucks. Kill the 31s. They're gone. Why? Because one's at the top, one's at the bottom, and it's multiplication. So that will cancel. And what can I do here?
10 over 2.
So the answer,
2.
2. Cool. So what I got? Yay, Jeff. I'm always concerned when I do it on the board. I'm like, I don't remember getting that answer right. What's up? You got? You gotta go? Go ahead. Thank you. Man, I was gonna sell that on eBay.
How about G? 1G.
Where are we at?
Number 1G.
1G. So again, just like there, I can't add fractions unless I have the same denominators, right? So let me try one last time. Math says you cannot add fractions unless they have the same denominator, right? In fact, not just math, humans say that. Math is just something we created to remind everybody that's true. Right? So humans say you can't add fractions unless they have the same denominator. Does that say anything about if there's x's or y's or 3's or 5's in it? No. So math doesn't care what's in it. It just says if it's a fraction, you can't add it to another fraction unless they have the same denominator. Right? It's just true. So do these have the same denominator? Do these have the same denominator? No. So how do you start to work towards that?
Even x2 on the.
Yeah, can you just, hey, I got it, yeah. So can you just do this? Of course not. Why not? What's the only thing you can do to the top and bottom of a fraction? Multiply or divide, which is really the same thing. Right? Because otherwise you're telling me that 1 over 2 is the same thing as 2 over 3. Because I added 1 to the top and bottom, right? That's not silly. 1/2 is not the same as 2/3. 1/2 is the same as 2/4. I can multiply top and bottom. So I can't do that. But I can't see very easily what I'm missing until I do what with this guy? Yeah, I got to see what it's got. I got to see what's in there to see what the other guy is missing. So how do you factor this? So they both have an x. So of course this guy is just missing x plus 1. Now do they both have the same bottom? Yes, they do. And now you can put them together. So what do you get? You get 3x plus 2x plus 2 over this 5x plus 2 over that. What's on the answer? So, I mean, really, watch this, watch this. Can you add these? Can you add these? No, please don't. You can't, because they are not like terms. So when you add or subtract, you must have like terms. Like denominators is just a type of like terms. Can you do this? Of course you can. What do you get? X times x squared is? X cubed. Do you need like terms when you multiply? Not really. You need like bases and all that kind of shit. But the main thing there is when I multiply fractions, I don't have to get an LCD. That's silly, because what am I doing when I'm multiplying fractions? I'm trying to reduce things. I'm trying to do the opposite of LCD, making things bigger, right? So I have a few people that still do this. I'm not picking on you, because there's several of you, and I want to make sure nobody else does this. I get like 4/5 times 10 over 12, and what are you trying to do, Jeff? I forgot. Oh yeah, so then they make this, they change this into 60, so this would be 48 over 60 times 50 over 60. You guys get an LCD? And then they get 2400 over 60. Do you see the logic behind that? Although it's very flawed, I see this kind of thing all the time. Because when you add fractions, the bottom doesn't change, right? But then I asked them, so 60 times 60 is 60? What? So if you actually did the right thing, if you multiplied these, this would reduce to the right answer. But why are you making everything bigger than it has to be? Holy shit. So no, you don't need LCD here. What would you do? You want to do the opposite of that. 2/3. Bam. Done. Right? Because it's multiplication. Multiplication does not need like terms. Addition and subtraction needs like terms. And that's just what like denominators are. So you only need LCD when you're adding, subtracting because of what I just said. I think that's one reason why people hate fractions. They're like, it does different things. Why does it do? No. It does what it has to do in the situation.
4i.
Okay, so that one's related to this. Because the only difference is if I have fractions inside of an equation, what am I allowed to do that I was not allowed to do here? See, the bottom is still here? Of course the bottom is still there. How could it possibly go anywhere? But what can I do with an equation that I can't do otherwise? What can I do with fractions inside an equation? So if I look at, what was it, 4i? So let's see, what's the steps here? Yeah, factor the denominator so I can see what it's got, so I can see who's missing what. Right? So how do you factor x squared minus 9? So now who's missing what? What's this guy missing? And is that good? Is that all we need? What's this guy missing? He's missing everything. Shit. Alright, so trust me, that's what it says now. Once I give everybody the same bottom, it's in an equation, so what can I do with an equation? What's beautiful? Everything's being divided by something, so what can I do? Since it's an equation, I can... What can I do to both sides? Multiply. So if I multiply both sides by this, it cancels everywhere. Do you guys see that? Do you guys understand? I can't read you. I can't tell if this is, I know how to do that, or this is, what the hell's going on? So what's left?
X squared.
X squared? Right.
Minus 3. Minus 9.
And then this is just going to be x squared minus 9, multiply that back out. Is that cool? So multiply everything back out, and now what's kind of wrong with this problem, and actually it'll fix itself. What happens to my x squared terms?
Cancel out.
Cancel out. And what's nice, if those cancel out, what's nice about that? Why do I set things equal to 0 when there's an x inside it that has a higher power than 1? Well, they died. So what can I do now? I can just solve like normal. I don't have the higher powers anymore. So now I can just solve like normal. The funny thing is, when I add 9 to both sides, what do I get?
0.
And this is where people freak out sometimes, but I don't care what's on that side. How do I get x by itself? Divide by -3. People think that's going to mess them up. Don't think about what's on that side. No matter what's on that side, you're going to divide by -3. You don't give a shit what's on that side. You got to get rid of the -3. And what's 0 divided by anything?
0.
Yeah. And is that okay for an answer? Does it make anybody undefined? No. Right? What makes it undefined? If it was... If x was what? -3 or 3. That would make the bottom 0, right? So that's the answers I could not get. I didn't get that answer. Good. That works.
Do you mind going over some of the graphing ones? Like,
Yes, I do.
6A?
Oh. Oh, yeah. So this is the one you got to graph the line and then shade. Remember those? Because there's an inequality, so you always get a lot more answers with inequalities. 6A, once you know 6A, 6B is just doing 2 lines at once. That sounds like a different activity. That's all right. What do I do first? Somebody got it. What do I do first with this? What does Jeff want you to do first with this, just to keep this fresh? How do you graph the line?
Don't you want to get y by itself?
Sweet, so
add 3,
kick ass. Divide by 2. Teamwork, I like it. All right, so what do I know about that line? Where do I start? What's the
Positive 4.
+4 where?
Y.
Y. All right, so 0, 4. That's the y-intercept. And then I would want to do what? I like what you're thinking. You just got to be careful.
Slope.
Sure, slope. The slope would tell me normally to go up 3 over 2, right? Let's pretend like this is the top of my paper, and I'm like, I don't want to erase that shit. What else? What could you do? What's 3 halves mathematically the same as? I don't want this to be a big deal. I want you to realize if I can go up 3 over 2, I should be able to go back 3 down 2. I'm still on the line, right? So 3 over 2 is the same as -3 over -2, is it not? Isn't that true? So math goes, what the hell are you doing? But we go, math, dude, leave me alone. Visually, this means something different. This tells me to go down 3, over or back 2. Right? You could always do that. Or you just make this longer if you got more room on your paper and go up 3 over. Who cares? You get the same. If you go up 3 over 2, you're on the same freaking line. Who cares? Maybe. What kind of line is it going to be? What do I mean by that question? You're like, what do you mean? What kind of line is it going to be?
Positive.
No. What are the options for this kind of problem? Either, oh shit, who remembers? It could be solid or dotted. So which one? I think somebody said sodded just to cover their ass. Solid, because you're allowed. I like it. One of my students a few semesters back said, if you see a line, draw a line. I like that. He actually said it sort of like that. If you see a line, he's allowed to equal it. So you want to make a solid line. Dotted line is sort of related to the old open circle idea, right? If that wasn't there, it would be a dotted line. But that line is there, so I make a line. I make a solid line. Wow. How do I tell which way to shade now? I like it. So one way you can do it is it's greater than or equal to, so I would go up and I'm done. Right? Or you do a test point. If you test 0, 0, is 0 minus 0 greater than 8? Is 0 bigger than 8? No. So the answer can't be on this side, it must be on the other side. You could do a test point if you want to. Or you could just shade in the direction this tells you to shade. Up or down. Either way. And then so 6b is just do this once, shade, do it again, shade. That's what 6b is. Just do 2 lines. Yeah. All right. I can tell some of you guys are like, I don't care what grade I make, just make it be over. Please. I remember that feeling.
Is 7 similar to
No. I mean, 7 is finding equations of lines. Right? 7. So using mx plus b or y minus y1 equals mx minus x1. Yes, ma'am.
On 1D, how did you get 3y14 over 5x13? Because I guess it's something else.
Let's see. I don't know. Let's see. Oh, that's a really good question. I don't know. I did some neat shit. So my number on top is wrong. So let's do that one together. Let's do this one step by step here. All right, so help me out. What should this be when you reduce this?
5
over 8.
Well, 8 over 5, right? So I put a 3 there just to be different. Obviously, I put the other number there, right? So it should be 8 over 5. But what about, now, this is more than a suggestion, but at the same time, you could certainly, what's the rule when you divide? What do you do with powers when you divide? What's the rule? Subtract. So you could totally do negative 6 minus 7, 7 minus negative 7. But then people make, see, I'm sorry, Asia, but I've got to use an example. That's the mistake. It's so easy to make negative mistakes. That's why I prefer what happens with negative powers. So these want to go,
down.
what's the only other thing that wants to move? Yeah, these want to go up. So now I've got these 7 x's were there. Those 6 x's came down. Those 7 y's were there. Those other 7 y's came up.
Yeah.
Now look at that. There's no freaking negatives to mess this up because I got rid of them. I did what they wanted to do. So how many y's I got on the top? 14. How many x's I got on the bottom? 13. And you see, negative 6 minus 7 is negative 13, and then you would flip it down because it's negative, right? So you'd have to do 2 steps there. 7 minus negative 7 is 7 plus 7 is positive 14. So as long as your brain did that correctly. And I'm really good at math. I am. Hopefully you're like, well, we hope so, John. But I will sometimes make a mistake and say 0 myself because I'm human. So I know how to avoid going the route that's going to let me make more mistakes, so I don't go that route. So the first thing I do is get rid of my negatives, move them, so they're not negative anymore. It's really nice when you're allowed to do that in math.
You put 3 y.
I know, I totally did. That's why we just did it together. So it shouldn't be a 3 there, it should be an 8. I like it. So I just left off my backwards facing 3 to make it a full 8. All right. If I don't make at least one mistake on a test, I get worried about myself. Like, was I replaced by a robot? No, I still believe it. Okay. Yes?
Can you do also, 1E?
1e. Oh, okay. Yeah, on that one I skipped just one step at the beginning. Just so I could get this key made in time for class. But let's see if you guys pick up on it. So 1e. Okay. So I still have people who are doing things like 45 and 5 reduce. So help me out. What would you tell that person? What would you tell them to help them out? You wouldn't tell them anything. You're so mean. Wow. You're like, go ahead, make a mistake. Why is that wrong? I mean, 5 goes into 49 9 times, right? Why is that wrong? Yeah, you can't break into a subtraction. You can't. Division can't kill part of a subtraction problem. It just can't. It can only kill part of a multiplication problem. That's what it was built for, right? That's what division does. So that's why we factor everything, because then I'm making it into a bunch of multiplied stuff. And then I can start killing parts with division, right? So I just factor everything I can. How do I factor the top here? Yeah, for some reason, a lot of us, not just you actually, but a lot of us think that 5 times 8 is 45. No. Right, that kind of mistake would make it become a really horrible problem. What is the bottom here? Yeah. Big dude, little dude, XXX. So I put here.
X minus 3.
Good. X minus one of these 3 3s. The other 2 X's. Plus 3X. The other 2 3s. And what does that look like it's going to be related to? What happens here? Take out an X. So before you go crazy trying to factor this, just take a look in the problem, right? And then the bottom is already factored, basically. So that dies, die. What can I do with this? Let's take the 5 out of there, right? Is that okay? How do you factor x squared minus 9?
X plus 3, x minus 3.
And then what happens? What happens here? 1x cancels, so I have, good, 2 left on the bottom. Kick ass. So then just consolidate what you got left on the top. I just have x plus 3. And on the bottom, I have x squared. Yay! All right. Wait, did I get that one right? Yes. Good job, Jeff. Just about to pass this course. But see, that's the thing about math. It always sounds like a cop-out when a math teacher says this, but I have that saying on my outline, homework outline. Math isn't about always getting the right answer. It's about knowing what to do when. That's what math is. We're human. We're going to make mistakes. If you watch basketball, there's good basketball players. They make mistakes sometimes, even though they're really freaking good. And you're all like, but you take points? Yeah, that's my job. I get to do my job. You guys are so funny. If you want to go, you can go. Remember this guy did. I thought when Andrew left, I thought there'd be a tidal wave of people. If you are about to head out, Monday, remember I have normal office hours, so
you will be in your office
at the normal times.
Uh-huh.
Yeah.
So what's your normal time?
I can't remember right now. Let's see, Monday, 11:30 to 10:30. 11:30 to 12:30.
11:30
to 12:30.
to 12:30.
And then 2 to 3. Oh, yeah, I'm sorry. I forgot to say that. I just put in the computer and gave it back.
Oh.
There's no time to grade them.
Little.